Hello, welcome back once again. Today we have this interesting exponential equation. X raised to the power of x is equal to 51. So in this video we're going to figure out the value of x that will satisfy this equation. Let us check the following. Let us know if x is integer or not. We know very well that 1 raised to the power of 1 is equal to 1, right? We know that 2 raised to the power of 2, this is equal to 4. We know that 3 raised to the power of 3, this is equal to 27, right? And we know that 4 raised to the power of 4 is equal to 256. Now, did you observe that 27 is less than the 51? And here, this one is far away greater than the 51. So this is telling us that our solution lies between 3 and 4. So we can say that 3 is less than x, and x is less than 4. So this shows that x cannot be an integer, right? Okay, now let's solve this problem. We have x raised to the power of x. So this is equal to 51, right? So let us start using the natural logarithm, okay? So we're going to ln both sides of this equation. So from the left hand side here we have the ln of x raised to the power of x. So this is equal to, from the right hand side we have the ln of 51. Now we know this property of logarithm. When we have the log of a to the power of b, this is simply b multiplied by the log of a. We call it the power rule, right? So here at the left hand side we're going to have x multiplied by the ln of x. So this is equal to the ln of 51. Okay. Now this left hand side we're going to do something very cool. Okay, so we know that a can be written as e raised to the power of ln of a, because we know with the e and the ln they get cancelled and we're left with a. Now what happens when we raise both sides to the power of b? Something like that. Okay, so if you raise both sides to the power of b, you still get that a to the power of b is equal to e raised to the power of ln of a times b, same as b times the ln of a. Okay, so here remember that the power of x here is 1, right? So the left hand side is going to be e raised to the power of 1 times the ln of x, which is same as ln of x. Then we have multiplied by the ln of x. Then this is equal to the ln of 51. Now we're going to use a very nice function here. It is called the Lambert-W function, or the product logarithm. Okay, so this is the property of the Lambert-W function. When we have the w of k times e raised to the power of k, where we see that the power of e here, k, is equal with this expression here. So this is equal to k, right? Now this left hand side is similar, right? The power of e ln of x is equal with this right over here. So we can write that as the ln of x multiplied by e raised to the power of the ln of x. So this is equal to the ln of 51. Now using the Lambert-W function on both sides of this equation. So the left hand side simplified nicely to ln of x. Then this is equal to the w of the ln of 51. Now we're going to take a common base of e on both sides of this equation. So here e raised to the power of ln of x is same as e raised to the power of the w of ln of 51. So from the left hand side these both get cancelled and we're left with x is equal to e raised to the power of the w of ln of 51, and this is roughly approximated to 3.296 298 then 598. So we can see that x is indeed between 3 and 4, as we stated earlier that 3 is less than x and x is less than 4, and we can see that this right over here is bigger than 3 but less than 4. Therefore this is our solution. Kindly support the channel by subscribing, also like, comment and share.